So first, coming to the radioactive symbol, it's a uh, three-petaled design, which has you can see there's at the center there is a circle and there are three petals. This design was first conceived in 1946 by the University of California, Berkeley, and since then it is being followed. And the meaning of three is, since considering this is radioactive material, so in all the directions radiation is will be coming out of this source. So it's saying that it goes in isotropic direction, means it goes in all the 360 degree of radiation. And since the primarily concern of radiation is alpha, beta, and gamma particles, so it represents that also. So three kind of primary radiations are there: alpha, beta, and gamma. So three petals are there, and it is in the circular shape. And this yellow color and black color is given because they are contrast in nature, and certain material which are transported with the red color code, so they may be more dangerous, like explosives, like petroleum products, they can have a red symbol. So relatively it is considered, so it is a yellow color. And since the yellow has got black has got more contrast with the yellow, so black is used here. So it has a simplified and balanced symmetry, and strikes a harmony between simplicity and abstraction, easily distinguishable since it is a simple and clear shape which enhances the recognition. And more petals, I was thinking, why three petals, why not we have four petals, means all the four directions, north, south, east, or west, so all the four directions. So that would not have given any more information, uh, and the more cluttering would have become. So that is why a simple design, and which says all the messages what it has. So this has been considered for the radioactive symbol. Now coming to the definitions, there is something called a spatial form of radioactivity, and there is something called non-spatial, means other than the spatial form. The spatial form means the radioactivity is in solid radioactive material, or the sealed sources which are used for the QA purposes most of the time. So those are a special form of radioactivity. And other than those special form, or the liquids or the capsule, whatever we are using for the treatment or for the diagnosis, those are called as non-special form, or the general form which is used for the general use. So whatever, so two categories: special form and the general form. The special form of radioactive material is the material shall be either an indispensable solid radioactive material or a sealed capsule containing radioactive materials. There is something called A1 and A2 values. A1 values shall mean the maximum activity value of a special form of radioactive material listed in AERB, or the IAEA regulations, which can be transported in the type A packages. And A2 shall mean the maximum activity value of radioactive material other than the special form and listed in IAEA and AERB guidelines, that can be transported in the type A packages. Type A packages will be seeing in the forthcoming slides. So A1 and A2, there are certain values are defined by the IAEA. So A1 is for special form of radioactivity, and A2 value is for other than a special form. Other than a special form can have a liquid form, it can have a capsule form. So the limits, so the chances of spillage become more during this in this form of radioactivity. So what IAEA has done has reduced the limit for the A2 value, whereas for A1 value, which is of solid indispensable radioactivity, there is certain limits are more for the A1 values. We'll see in the next slide. So see, this is the A1 form of radioactivity, and a special form of, and this is the this is used for the A2 form, means a general form of radioactive materials. There are different limits are given by the IAEA for different radioisotopes, and it is given for the A1 and A2 value, and it is given in TBQ, terabecquerels, and for the cobalt 60 it is 4 into 10 to the power minus 1. For A2 value again it is same. See, for the cesium 137 it is a 2 into 10 to the power 0 means 2, and it is a 0.6 for cesium 137. Similarly, this table says about activity concentration for exempt material. It's means there are certain radioactive material which can be which does not require these regulations. So how much those regulations are required, so it can be, how much those limits can be applied, it can be drawn from this. It's in becquerel per gram. An activity limit for exempted consignment. So as a whole consignment, how much activity concentration is there, so that can be exempted, it is given in this limit. So since our thought process generally work in millicurie, so I have changed those terabecquerels in the millicurie. So for cobalt 60 or the cesium 137 which we were discussing, it was 2 terabecquerels, so that says about 54.1 curie of activity it can be transported when if it is in the sealed form, and if it is in unsealed form then 16.2 curies of activity. Means if it is sealed, 54.1 curie can be transported, and if it is 16.1, if it is in liquid form or other than the special form, only 16.2 curie of activity can be transported. Likewise, it is given for other isotopes, which includes the F18, means 27 curie of activity can be transported if it is in special form, and 16.2 curie only can be transported if it is in the non-special form. Simplifying this table, I am removing all terabecquerels and coming only in the curies and microcuries. So this table says about all those limits in the curie and millicurie. So for gallium 68, it is a 13.5 curies, and it is same for both the conditions. So that depends upon isotope to isotope. These values keep on changing, and this is how the IAEA says about all these radioisotopes. There are different isotopes are given. So whatever is useful in nuclear medicine, that I have taken in this table. So you can, if you wanted, I have whatever the references I have said, that can be used for referring other isotopes. Now something is called exclusive use, and exclusive use shall mean the sole use by a single consigner. Means if it is going to some particular person or the particular industry or the particular consignment, particular consigner, so it is going for the exclusive use. Means it will be used only for that person. So that is called as a exclusive use. So definition is exclusive use shall mean the sole use by a single consigner of a conveyance or a large freight container in respect of which all initial, intermediate and final loading and unloading is carried out following the directions of consigner or the consignee. There is something called surface contaminated object. We just saw some solid material which can have some contamination on their surfaces. So how much contamination can be there? That different limits are given, SCO1, SCO2. So the surface contaminated object shall mean a solid object that is not itself a radioactive material but has radioactive material distributed on its surface. That is called surface contaminated object. So how much contamination is allowed, and what is the definition of contamination? So the presence of radioactive substances on a surface in quantities in excess of 0.4 becquerel per centimeter square for beta and gamma emitters, and low toxicity alpha emitters, or 0.04 becquerels per centimeter for other alpha emitters. The non-fixed contamination, the contamination that can be removed from a surface during routine conditions of transport, and the fixed contamination other than the non-fixed contamination. This is what is non-fixed. The other than the non-fixed is called as a fixed contamination. So if it can be removed, then it is a non-fixed contamination. If it cannot be removed, then it is called as a fixed contamination. So only up to 0.4 becquerel per centimeter square for beta and gamma, and 0.04 becquerels for alpha if it is present and the area which is taken is 300 centimeter square is taken to evaluate how much contamination is there.